Number 33, find the horizontal asymptote of the given function. H of x equals 36x squared over 9x squared minus 6. To find horizontal asymptotes, you want to know if the function is top-heavy, bottom-heavy, or balanced. By doing that, you look at the degree of the numerator and the degree of the denominator. This rational function is balanced, and looking at the degree of the numerator is 2. The degree of the denominator is also 2. So it's balanced. The way we determine the equation of the horizontal asymptote is by looking at the leading coefficients. The horizontal asymptote will occur at y equals 36 over 9, the leading coefficient of the numerator and the denominator. When you simplify it, y is equal to 4. So choice C is our answer. Number 34, give the equation of an oblique asymptote. The oblique asymptotes happen when the degree of the numerator is exactly one more than the degree of the denominator. And this is the case. We look at the degree of the numerator is 2 and the degree of the denominator is 1. Now the way we find the equation of that oblique asymptote is by using synthetic division. We're going to divide it out and rewrite this as, here's our setup for synthetic division. Since we're dividing by x minus 2, we put a 2 in the box, and then we use the coefficients 1x squared plus 9x minus 2. Use the process of synthetic division. When you multiply, and add, then this function, f of x, can be written as the quotient and the remainder. Well, since we started off with an x squared, our quotient is reduced by 1 power, so our function can be written as 1x plus 11 plus the 20, which was the remainder, over what we divided by. The oblique asymptote is found by looking at the whole part of the quotient without the remainder, which is choice B. So if you're graphing this, you would graph the equation y equals x plus 11 as a dotted diagonal line, and that would be your oblique asymptote. Number 35, give the equation of the oblique asymptote, if any. Again, the oblique asymptotes only occur when the degree of the numerator is 1 more than the degree of the denominator. So if we look at the degree of the numerator is 2 and the degree of the denominator is 2. So this is a balanced function, and it's not going to have an oblique asymptote. No oblique asymptote. So our correct answer is B. And the oblique asymptotes only occur when the degree of the numerator is 1 more than the degree of the denominator.